Good morning, everyone, and welcome to our presentation for quality engineering. We are Group B4, and today we will be diving into the cost of quality optimization in manufacturing industry. My name is Muhammad Daniel Faiz Jazrulizam, and I am joined by my group members Siti Hasina, Wanur Aina Anisa, and Muhammad Irfan Afandi. Over the next few minutes, we'll explore how optimizing this cost can drive efficiency and reduce waste. Let's get started. Moving on to our introduction. First, we need to understand what the cost of quality or COQ actually is. Essentially, the total cost a company incurs to ensure its product meets strict quality standards. This is generally broken down into prevention, appraisal, and failure costs. The most critical component here is the cost of poor quality (COPQ) because this is the area that directly eats into profit margins. When product quality slips, it creates a domino effect. We aren't just dealing with internal manufacturing headache like defects, the need for rework, or scrap materials. It extends outward to customer complaints. This dual impact, rising internal cost paired with dropping customer satisfaction, is a major threat. To combat this, companies have to rely on robust quality management strategies. By utilizing structured methodologies like Six Sigma, organizations can systematically track and reduce the defects, lower their overall costs, and massively improve their operational efficiency. Let's move on to the specific objectives of our project. What are we actually trying to achieve here? Our primary financial goal as least first is to significantly reduce the cost of poor quality. To make that happen, we have to target specific issues happening on the line which brings us to our second objective, eliminating inclusion defects. In manufacturing, inclusions like thread particles, foreign materials, or air pockets compromise the integrity of a product and are a major driver of scrap and rework. We want to bring those occurrences down to zero. To tackle this defect systematically, our third objective is to analyze the root causes of this rejection using the DMAIC framework. By walking through the structure phase of define, measure, analyze, improve, and control, we can work away from guesswork. We will rely on data-driven, continuous improvement principle to isolate exactly where the process is failing and permanently solve the issue at its source. Ultimately, by successfully applying this framework to target those specific defects, we will naturally achieve our final two objectives, improving overall process performance and driving up goods quality and productivity. When we eliminate the root causes of errors, our manufacturing line becomes leaner, more efficient, and ultimately more profitable.
Next is problem statement. The main problem identified in this case study is the high rejection rate in cylinder block casting, which is mainly caused by inclusion defects originating from supplier-related quality issues. The company recorded an average rejection rate of about 37.6%, with some cases reaching as high as 80%, indicating a serious quality control problem. These defects occur when unwanted materials, such as slag, become trapped inside the casting during the metal pouring process. Contributing factors include improper pouring temperature, low sand strength, and poor sand compatibility. What makes these issues more critical is that the defects are only detected after the machining process, which significantly increase the production cost, material waste, and time consumption. As a result, the company faced high scrap rates, increased cost of poor quality, production delays, and reduced supplier performance. This situation highlights the need for a more structured and effective quality improvement approach to reduce defects and improve overall process efficiency.
Now I will explain the methodology used in this study. This study used the Six Sigma DMAIC method, which stands for define, measure, analyze, improve, and control. This method helps to reduce defect and improve process quality. It is also data-driven, meaning that all the decisions are based on actual data, not assumption. Okay, so For the first phase is define. In the define phase, the main problem is identified. The company faced a high rejection of 37.6% and the main defect is inclusion defect, which contribute about 72% of total defects. This problem occurs during the metal pouring process and leads to high cost of poor quality. Second phase is the measure phase. In the measure phase, data such as rejection rate, pouring temperature, and also the sand condition were collected. Statistical tools like graph and t-test were used. The results show that there are many process variations and the rejection was still around 60% to 90%. For the third phase, which is the analyze, in the analyze phase, the root causes were identified using Pareto chart analysis. The main causes are the incorrect pouring temperature, poor sand quality, and slag entering the mold. After the improvement, the rejection reduced to about 8% to 11%. This step is very important because it focuses on identifying the root cause, not just the symptoms. The fourth phase is improve. In the improve phase, solutions were implemented. The company collected the temperature, improved the sand properties, and added a slag control system. As a result, the rejection reduced from 37.6% to around 8 to 10%. Also, the production increased from 700 to 2,000 units per month. The last phase is control. In the control phase, the improvements are maintained. The company implements 100% monitoring, data logging system, and standard procedures. This ensures the process remains stable and also consistent.
Next, we move to case study scope. In terms of the case study scope, this study is conducted in an automotive manufacturing supplier that produces cylinder block castings. The focus is mainly on the casting and metal pouring process, as this is where most of the defects occur. The scope includes analyzing the types of defects, especially inclusion defects, which contribute to around 72% of total rejection, evaluating supplier quality performance, and measuring the impact of rejection rates on production costs. In addition, the study examines data collected from the production line, quality inspection, and supplier records to better understand the root cause of defects. Another important aspect of the scope is the assessment of the cost of poor quality, which reflects how defects affect overall company performance. Overall, the study concentrates on improving the metal pouring process using a structured method, making it highly practical for real industrial application and useful in achieving better quality, lower cost, and improved productivity.
Okay, now I will explain about the finding of this study. The result shows that significant improvements after applying the Six Sigma method, which is the DMAIC, define, measure, analyze, improve, and control. The main results show that the rejection rate reduced from 37.6% to below 10%. Second, the production increased from 700 to 2,000 units per month. The last is annual cost saving reached about 14 million. In conclusion, the DMAIC method was successfully improved the quality, reduced the cost, and increased the productivity. This thing shows that small process improvement can lead to a significant result on the process.
Okay, Six Sigma through the DMAIC approach play a crucial role in reducing process variation and minimizing defect, which is directly lower the cost of poor quality COPQ. From the critical insight, it is clear that many quality issues originate from supplier inconsistency and process failure, but even small adjustment in key parameters, such as temperature and material compatibility, can lead to significant improvement in product quality. By relying on data-driven analysis, DMAIC help identify root causes accurately and ensure that decisions are made based on evidence rather than assumption. Furthermore, standardization of processes is essential to maintain long-term stability and consistent performance. As highlighted in the conclusion, the implementation of Six Sigma not only reduces rejection rates significantly by up to 75%, but also enhances efficiency, lower operational costs, and increase overall productivity. Therefore, Six Sigma is a powerful and valuable methodology for achieving sustainable quality improvement and operational excellence in manufacturing. That's all from us. Thank you.